Robotics represents the physical embodiment of artificial intelligence, transforming algorithms into tangible machines that interact with and reshape our world. From manufacturing assembly lines to exploratory space missions, intelligent robots are expanding the boundaries of what machines can accomplish. Modern robotics integrates multiple AI disciplines: computer vision for perception, machine learning for decision-making, and reinforcement learning for adaptive control. This convergence creates systems that can perceive their environment, make intelligent decisions, and execute precise physical actions. Industrial automation has been revolutionized by robotic systems that perform tasks with superhuman precision, speed, and consistency. Collaborative robots, or cobots, work safely alongside humans, combining human flexibility with robotic precision in manufacturing, assembly, and quality control. Autonomous vehicles represent one of the most ambitious robotics challenges. Self-driving cars integrate sensor fusion from cameras, LiDAR, and radar with real-time decision-making algorithms to navigate complex environments, promising to transform transportation safety and accessibility. Medical robotics is advancing healthcare through surgical systems that enhance precision beyond human capabilities, rehabilitation robots that assist recovery, and telepresence robots enabling remote medical consultation. These systems improve outcomes while expanding access to care. Service robots are entering daily life. Robotic vacuum cleaners maintain homes. Delivery robots transport packages, and agricultural robots monitor crops and automate harvesting. As costs decrease and capabilities increase, service robots are becoming increasingly ubiquitous. Human-robot interaction focuses on creating intuitive interfaces and natural communication between humans and machines, from gesture recognition to natural language commands. Improving interaction makes robotics more accessible and effective across applications. Swarm robotics studies how large numbers of simple robots can collectively accomplish complex tasks through local interactions and self-organization. Inspired by insect colonies, swarm systems show promise for applications like environmental monitoring, search and rescue, and construction. Soft robotics represents a paradigm shift from rigid mechanical structures to compliant, adaptable bodies, using flexible materials and novel actuation methods. Soft robots can safely interact with delicate objects and navigate unstructured environments, opening new application possibilities. As robotics advances, ethical considerations gain importance. Job displacement concerns, safety standards for human-robot interaction, and the appropriate boundaries for autonomous decision-making in critical situations. The future points toward more general-purpose robots that can learn new tasks through demonstration or instruction, adapt to novel situations, and collaborate effectively with humans. This evolution promises to create versatile robotic partners that augment human capabilities across work, home, and society.